Hello everyone, welcome back to my YouTube channel Code with Rex. Do you want to go into machine learning in Python, or you want to go into data scientist, or you just want to improve your knowledge and skills in Python? You learning NumPy is the right decision. So in this mini series, I'm going to be teaching everything you need to know about NumPy library in Python. You must have heard of the word list in Python if you are good with Python or you have been using Python. So NumPy, arrays and lists are kind of similar, but in this course, as you go on in this course, you're going to be seeing the difference and why you should use an array and not list in some situations. So these are the things we're going to be covering in this course. We're going to be going through an introduction to array, then dimension in NumPy array, and under this introduction you'll be seeing difference between a list and an array, and what an array is, and the key and characteristics of an array. I'm going to be going to indexing a NumPy array. So we're going to be slicing an array, then we're going to be going to iterating a NumPy array, then we're going to be concatenating a NumPy array. I will slice in twice, and we are going to be going to arithmetic operation on NumPy array and statistics operation on NumPy array. Let's get started now. What's an array? An array is a data structure used to store multiple values in a single identifier variable name. So an array is just a data structure now that is used to store multiple values. As you can see here, my array here is storing multiple values now and is only identifying it as this my array. So we just use this my array to store all these values now. Instead of saying our normal variables now, we can just say no1 equals to 1, no2 equals to 2. That's we're having two identifier there, which is no1 and no2. But here now we're having an array storing 1, 2, 3 up to 6 in just a single identifier, which is a variable name here. It contains a collection of data elements where each element is of the same data type and can be referenced by index position in the array. So now we can see that in this array called my array, which is array is short for ARR, we set the same number. All these are the same data type, right? It's not say we are not having character here, we are not having string here, we are not having any other type of data type like boolean data type here. We only have a digit here. So we can see now we cannot access each element here. We are still using this identifier, this variable name. We cannot access this element here by the index, which is the position. And then we have where my array and the index of 0 now is this 1, an index of 1 is this 2, and index of 2 is this 3 here. So this is how array work. So now we are going to have characteristics of array. What are the characteristics of an array? Each element of an array have the same data type. As we've said before here in the introduction, each element of an array have the same data type. So example here now, we can see this my array here, they are of the same data type. It's just, I'm not saying that it can only be numbers, because I think as you can see that I use numbers as example here. This also can be just names, can just be like my names, can just be of array, and they all be string. Each element of an array is referenced using name of the array along with the index of the element. So if you want to reference each element here, you are going to use the name of the array and the index of the element you want to reference. As you can see here, we use the name of the array where my array is 0, then we are referencing to this first here. Now we can see here the name of the array and the index we want to reference. These numbers in this array are called elements. So to reference each element, we use the name of the array itself and the index of the element. An index starts from 0, that's 0, 1, 2, 3, 4, 5. So that's how we do it. So now the index of an integer is an integer value associated with the element based on the element position in the array. So what are index? Index are just, they are a value that they are associated with each element. It's an integer value that's associated with each element. So as you can see back here now, this integer value 0 is associated with the element 1, and this integer value 1 is associated with the element 2. So this is how it works. So now the index of the first element is 0, and the index of the last element is the size minus 1. So as we've said before now, this will be 0, 1, 2, 3, 4. And you can see now we have 5 elements here, but now the first index is 0 and the last index is size minus 1. What do you mean by size minus 1? That's the size of the array. In other words, number of elements in an array. So we have 5 elements in this array now, which is telling us that the last element will be size minus 1. That's 5 minus 1. That's the last element will be the index on 4. That's 0, 1, 2, 3, 4. So this type of index is called zero-based indexing. So this is what we call zero-based indexing. So the element of an array are stored in contiguous memory location. We will get more to understand what we mean by contiguous memory location as we go on. So now, what is the difference between a NumPy array and a list now? As I've said about list before, you can see array is part of NumPy module. For you to use an array, you have to install and import NumPy module for you to use an array. But list is part of core Python. You don't have to import anything, you just have to just define your variable there while using list. That's how you work with list in Python. An element in an array have the same data type. So we can see now you could either have just numbers or strings or character. This is how it works in an array. They must be of the same data type, and we will see the advantage of this very soon. And we can see element of list now can be different, can be of different data type. As you can see now, we have this array here, or this list here, 1, 2, and we have a string here, which is A. So they can be of different data type. So now, going to this now, elements are stored in contiguous memory locations. This makes the operation on array faster than list. So this element now, they are stored in contiguous memory location, and this is why any operation we are having with array are faster than when we are operating with list. But looking at list, they are not stored in contiguous memory location, and this makes the operation on list slower than arrays. So while working with list, our program will be slow compared to while working with an array. An array supports element-wise operation. And what do you mean by element-wise operation? We can see now, if x is an array, it is possible to write x multiplied by 5. And what is this going to do? It's going to multiply each element of the array by 5. So if you have this now, let's say we have this 3, 4, 5 now, I'm just saying, and this is set to x, I'm just say x multiplied by 5. Now it's going to return 15, 20, 25 as a new array for us. That's how it works. But list cannot do this. List does not support this element-wise operation because it may not be the same. So now imagine we are multiplying this by 5 now. If you multiply 1, 2, and a as a string by 5, it's going to be an error code. We can multiply this 2 by 5, but this cannot be multiplied by 5. And because list does not support, can be of different data types, so it does not support element-wise operation at all. So now going to this now, array take up less space in the memory because there is no need to store data type of each element, as each element belongs to the same data type. So now NumPy array only need to store the data type of an array once. If it's an integer, it stores it as an integer or a string, and like that by default, it knows that all the elements there are a string or all the element there is an integer. But coming to list here now, here where we have 1, 2, and 3, it has to store simply that the index 0, which is 1, is an integer, index 1, which is 2, is an integer, while index 2, which is a now, is a string. It has to store it specifically for each element in the list. So the list take more space in memory because it contains elements of different data type, and therefore the data of the element is also stored along with its value. So now instead of just storing these once, now it's going to store like two different things there for each element. It store the value of the element and it store the data type of the element. Why in the NumPy array here we only store the value and the data type is stored once to identify the data type of everything like that. So what are the attributes of arrays now? So as we go into NumPy array, we will be seeing the attribute of this thing we call ndim now, and this is to know the numbers of dimension axis of the array. This is not the number of dimension we have in the array, and we have shape. So shape now is a sequence of integer indicating the size of the array for each dimension. How do we mean by dimension? We can have like 1 dimension, 2 dimension, 3 dimension. So we get to know more about that as we go on. And size now is the total number of elements in the array. Size is the total number of elements in the array, and the type is the data type of the element in the array. While item size now is size in byte of each element of the array. So these are the core and main 5 attributes of NumPy. So let's talk about the type of dimension we're going to be working with array here. So we're going to be having 1-dimensional array and 2-dimensional array. There's also 3-dimensional array, but for the scope of this course, we're going to be really talking about 1-dimensional array and 2-dimensional array. So we can say 1-dimensional array is just like we have it in this format here, my array then set like a form of list of this. And we're going to have 2-dimensional array is just like our index, and we can see we have a bracket, then we have like subset of those brackets inside, and we can write it like this in way to understand it more and better. You can write it this way for us to understand it. So let's start coding this and start seeing how this works while using Python. So let's head over to Jupyter Notebook and see how this works. Jupyter Notebook is just it's just an IDE. I can say we use for data scientists and machine learning problem. You can use any other IDE you have, like PyCharm or VS Code. So that will work well for you. You just have to use pip install NumPy. Then all you just have to do is pip install NumPy. Then after this, you have to import NumPy. That's all you have to do. So, and we are going to get started. So we are talking about dimension arrays here, and we have a function in yours. Okay, let me have this as text. We have a function in NumPy, and that's the array function. We have the array function in NumPy, and this array function is used to create an array. Is used to create an array from a list. So how does this work now? So let's say we import NumPy now as NP. Okay, when we import NumPy now, this is how you just like import NumPy and it works well here. So I'm just comment it here to importing NumPy library here. So import NumPy as npm. So now what do we do now? Let's say we have my array here equals to np.array. So we are calling that function now, which talk about the array function. So we can just np.array now, then np.array now, then we have the list here. So we can just have 1, 2, 3, 4, 5. Okay, so this is just like one dimensional array now, as you've seen before. So I could just print out this my array. So if I should run this now, you see here now we have this now. We have it printed as one dimensional array. So this array now has converted this list into an array. So if you should print out, okay. So one of the attributes we have in NumPy is using the dimension, the size, and things like that. So we can print out my array now dot what dot okay ending. That's dimension for dimension now. Should print it out like this. Now you see we have it as one. That's one dimension. That means this is telling us that this array here is one dimensional array. So let me run this again. So now we have this now. These are array now. It's telling us it's one dimensional array. So this is our one dimensional array is, and this is how we are going to have one dimensional array. So let's work with various attributes of this array now. So we can just print out like okay, a attribute now. Attribute of an array, then we can have like okay, so the first attribute we have is the dimension, right? We have dimension here, so we have dimension equals to now, and let's have it as my array dot ending. Okay, then we also have the shape, right? We have the shape, can have this as okay, let's say we have it as my array dot shape. Then we can also have data type, that's the type, right? So you have okay, data type. So my array dot the type. Then we have the size, right? So my array dot size. Then we have the item size now. My array dot item size. So we could print out all this now and see how it goes. Now we can see that our dimension is 1 and the shape is 5, and the shape is like this because it does not have any other dimension. So we will see this when you're working with two-dimensional array now. You see different, and data type is an integer now, that's int 32. I have the size now to be 5. That's because it contains 5 elements. Now you can see 1, 2, 3, 4, 5. That's 5 elements now, and the item size is 4. So as you said before, the item size is just like the size of each element in the array as the item size, right? So these are the attributes of the array now. So let's have a two-dimensional array, and you can see okay, let's have it as my array2 here now. Have it as np.array. So we have it as this now. 1, 2, 3, 4, 5, 6. And we just like, okay, let's print out this array. Okay, my array 2. My array 2 now, and let's print out my 2 dots, the dimension, and let's see. So now we can see it this way. This is our array now. You can see it, we have it like this, and we also have like this, and we have it as two-dimensional array. So I personally like formatting my array this way for better visualization personally. If you try to print these properties, and let's just see it again for here, and let's just change all this to my array 2. Okay, let's have it as 2 here, 2 here, 2 here, 2 here. So if I should run this now, you see it. So we have the dimension of 2 now. We have the shape now, 2, 3. So as you can see here now, the shape here was 5, right? That's because we have just 5 elements like this on the x-axis. And here now we have 2, 3, right? So we have 1, 2 now. That's 2 now. And each we have 1, 2, 3 now. So it's picking the row first. We have 2 rows and 3 columns. So the row comes first when telling us about the shape, then followed by the column. So that's how it works with it, and that's how I do it. So now we have the integer to also be 36, and I have the size to be 6. That's the size, that's the total element we have in it. So the size is 6 now. That's the total element you have in it. And the item size is still 4. That's element you have for just one. The size of just one single element there is still 4. So there are also some functions in NumPy array, like also have something like the 0 function and the arrange function. So we have the zeros and arrange function, and you can do some things with this. So the first I'm going to be doing here now is just like, okay, we have to create a dimension, an array that is all 0. With this, let's say we want to create an array now of 2 rows and 3 columns now, just like this, but all the values inside are 0. That's where we use the 0 function. So we just say array now equals to np dot zeros, then we have this top inside 2, 3. So we could just print out array now, and now we can see it now. But you might be wondering, why is there this point everywhere? So if you check the dimension, the data type of this array now, see that it's giving us as a float and not an integer. So that's one of the functions you can use in Python. The 0 function is giving us not an integer, and there is also one I forgot to add, and there's also ones, and this one's to just create exactly the same thing here, but just like 1. So I will just copy this and paste it here. But let me just name this 2, 2, and let's change this to 1s. But now let's have it as 3 rows, 3 columns, right? So if I should print this now, you can see it, and if you should check the data type again, see that it's still float, right? So this is creating an array that is all populated with 1, and in this array now, using 0 function, are all populated with 0. So now if I have to use the arrange function, let me just have this as marked down now. This is the arrange function, and this is just to create an array full of numbers within some ranges of number, and we could have a step to it. So let me just add this as, okay, let's say we have array is equals to what now, np dot arrange, and let's say we want to create an array that is populated with values from 1 to 10. So by default, if you should print this out now, you will see we have 1 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just like 1 to 9. That is minus 1 from here. If you change this to 9, we see that we have 1 to 8. So these are it works actually. So this arrange works like this, but if you want to have it like it's going to have some step, let's say we want to have like arrange 2 now, it goes to np dot, okay, np dot. Okay, we have it something like, okay, let's say we have 1 to 20, I want it to have a step of 2. So it's going to start now, but it's going to have like a step of 2 each. So if we have this now, we have like AR2, and let's just print this out. You can see start from 1 now, then he added 2 to 1, that's 3, add 2 to it, that's 5, just like that, giving us odd numbers. But if you change this to 0 now, you see that it's giving us even numbers, right? So these are it works to create one-dimensional arrays with a range. And if you check the data type of both the first array we created and the second array we created, consider they are both integer. But let's say we have something like this now as our third array, and we have np.range. Okay, we have something like, okay, we have between 3 and 7. I have a step of 0.5, and now we print out this array, and let's also print out the dimension. So we can see now we have 3.5, 4, 4.5, 5, 5.5, 6, 6.5. So we're having it like this, and we can see that it is a float and not an integer like the previous ones. So this is how it works. But let's now say we want to create a two-dimensional array. How do we do that? We just have like, okay, let me say I have my array. Can I name this? Okay, let's say we have ARR. Okay, I'm telling you right now. We just have, we could call one of these array here. That's just AR.shape 1 to 10. That means we have, okay, 1 to 10, we have 1, 2, we have 9 here. We could reshape it as 3, 3. And that means we want this to have, okay, let me just print it out and see. We want this to have like 3 rows, 3 columns. Okay. Okay, let's check this again. 1, 2, 3, 4, 5, 6, 7, 8. Let me just run this one more time. Okay. So now we see this. It's reshaping it now. But the thing is, wherever you're reshaping it, it must be a factor of the size of the element before. So this is just the same thing as saying we have here 2 now equals 2. We just have np.arrange 1, 10. Then we just call this function reshape to it 3. So if I should print this out now, you see that it's the same thing just like this other one. Now it's just the same thing, just because we've stored this in this variable before, right here. That's why I was able to call it like that. So if I could just change this to 9 now, you see that it will return an error because it says it cannot reshape an array of 8 into a shape of 3 rows, 3 columns. So this will have to be either 2. If it's still 2, it won't work well. But if you change this now to 7, this will now be 6, right? Yeah, 6 values. So there's 2 and 3 are both factors of 6. So this is why this work well. But if I should change this back to 8 now, and I put 2, 4, where 2 and 4 are both factors of 8. You can see this now that it works quite alright. So that's how you create two-dimensional array while using a range function too. And this can also be just like here that we have, how many elements we have here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 here too. We could just say, and this we have them as AR3 dots. Okay, we could just like reshape. So now let's reshape this now. We have 8 elements here now. We could just reshape it as 2, 4, right? I could just print it out. AR2. I see this work quite okay. More than something else. So we could see it like this now. It reshape it and it prints it out. So we had 2 and 3 are both factors of that. So we can see this work well. So next we are going to be working with indexing NumPy arrays next, and let's see how it goes. Welcome back. So in this NumPy tutorial series, we're going to be talking about indexing and slicing. If you don't watch the two previous videos, make sure you go back and watch them. So in NumPy tutorial series now, we're talking about indexing and slicing. And what do you mean by indexing? Actually, at times you need to point to a specific element in an array. So indexing is how we point to or use a specific, let me put that like that, a specific element. So a specific element in an array. And what is slicing? At times we need to just extract some part of an array. So slicing is how we extract some part of an array. So how do we do this now? Let's get started with indexing now, and let's see. Okay, so what do we mean by indexing actually? So indexing now. So let's say we have an array now. We have just like, okay, let's say we have an array and let's name it A, and have it as np dot array, and let's have it as one dimensional array, and let's have it as 10, 20, 30, 40, 50. So in this array now we have 100 items in it. So if you just print this array now, there's an error somewhere. Oh, sorry, we didn't import. So let's import our NumPy np. So we have this way now. So if I should run this, so we have it like this now. So let's say we really want to print out this 10, or we really want to print out this 30 now. So as we all know that we are using zero-based indexing in NumPy, and it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are using it like that now. So we could just print out A now, then with square brackets we could reference to the index we want to print. So if we do it like this, you can see we are printing out 1, and if we should change this to, let's say, something like 3 now. If you change this to something like 3 now, we are printing out 40, right? That's because 40 is on the third index there, is on the fourth index, and that's 3. That's 0, 1, 2, 3, right? On the third index. So, and let's say we want to print out the last term, but we don't know the last term, and we don't know how many terms there is in the array. So, we remember that we could get the size of an array by just a.size, right? And it's going to tell us the size of the array, right? So, to print out the last array now, we could just simply say print yes, then a.size. But we know that since indexing starts from 0, the last item must be the size minus 1, right? So we're going to subtract that 1 from here now, and if we should print this now, we see that we are getting 100 the last time, right? So this is how it works now. So let's try and see two-dimensional array, sorry. So if you have np.array here, now, we could just have something like this. Okay, so let's just have, okay, 1, 2, 3, 4. Okay, let's have it as 1, 2, 3, okay, 4 now, and let's have, okay, so 5, 6, 7, 8. So if you have it this way now, and we want to print out, okay, let's print out the array and see. Oh, this is meant to be an open and close bracket here. So yes, we have it this way now. So what do we do now? Let's say we want to reference this. We want to reference this, so how do we do that now? So let's say, and here now we are going to have B and just two brackets. And why are we having these two square brackets now? We're having these two because we're having a row, which is this, and we're having column, right? And if you look at it here now, let me do it this way a bit. Okay, this is our column. 0, column 1, column 2, column 3. Let me see if this still work well. Okay, and this is our row 0, row 1, right? So we are going to specify the row here, and we are going to specify the column we want to reference in that specific row, right? So if I have to print 2 now, 2 is on row 0, right? So we put 0 here, and 2 is on column 1. So we put that 1 here now. If you should print this out, we are getting 2. So let's say we want to reference 7 now. You can see that 7 is on row 1 and this is on column 2. So we can print that out down. But let's say, okay, let's have a touch of three-dimensional array here, dot array. So let's have it like this now. We have this, and we have this 1, 2, 2, 3, and just this way 4, 5, 6, right? So I think you should start seeing why I like formatting my arrays this way. So it just allows for easier processing and accessing the way for better visualization actually. So I can have it like this too, and let just have as 7, 8, 9. So now you should have guessed that now when we are trying to access, let's just print out C first. Now we have it this way, and when we are trying to access a specific element, now we should be having how many square brackets? This is two dimension. This is just 2 dimension actually, not 3. So we have a row here. So this is row 1, 2, 3, and this is column 1. Sorry, row 0, row 1, row 2, column, and this is column 0, column 1, column 2 now. So we could just print out, let's say I want to print out 5 now. And we see that 5 is on row 1 and column 1. So if you just put 1 here, we could see that 5 now. So this is how we just use indexing to access a specific element. So let's talk about slicing now in Python. As I've said earlier, slicing is just a way that you use to print or extract some part of the text. So now let's print our array A now. We could say it like this now. We have 10 to 100, right? So let's say we want to print just from 10 to 50 now. From 10 to 50, how are we going to do that? We're just going to have like something like, okay, A now, then we have our square bracket again, and we're starting from index 0. I want to stop at the index before this now. So you can see from index 0 to index 5, it's actually going to stop at index 4. You can see this is 0, 1, 2, 3, 4, right? So that's why it's stopping at index 4. So if we were to just use this, we could just set it as to another variable entirely. So, and that's how it works. So let's say now I want to print just from index 40 now to the last index, and let's say we didn't know the amount of elements in the array. As we use a.size before here, we could use it again for something like that here now. So now we know that it's starting from index what? This is index 3, right? So we just say a now, 3, and we just say a.size. So now you see it now 40 to 100. But let's say we want to print the last 2 terms of the array, and we didn't know the number of elements in the array by default. So let's just see now we have it like this now. A, then we have it like this. A.size. We have like A.size minus 2, then our column A.size. So we have it like this. Now we're printing the last 2 terms of the array, and it was to be the last 3 terms. It will work quite alright. So this is how we like slice in Python. This is how we slice most things. But let's not say we want to have step as you're slicing. If you want to have step as you're slicing, what are we going to do to have some step as you're slicing? So we could just have it this way now. And yes, before we talk about step, we could have a reverse order, and that would just be like here, and we just have, okay, we could have -1. And now we can see we are reversing the elements. We are reversing them to give us in another format now. So that's how it works too. So now let's say we want to have step now. So if I should just like, okay, let me just have this and paste this here now. I could just have it this way now, and I could just have 2 again. And what am I having here now? You can see that I'm only printing the element now. In the even index size. That's because this is index 0, 1, 2, 3, 4. That's the even index. But if I should do it the other way around now, you see that I am only printing the index in the odd number. But you can see this one now. So this is like having a step now. So if I have to print right from, if I were to print all the element now, that would just be from index 0 to index 8 of size. And let's say we want to have even, we have it this way. And let's say we want to have, okay, index 0 to index 8 dot size, and we can have it as even odd A2, where you have, sorry, this should be 1. Have it as, okay, this is even and this is odd. Okay, we have it like this too. So this is how it works to slice and to perform some slicing operations. You can practice more on how to do this and check out what you can do with all this. So we are going to be moving to slicing two-dimensional arrays now. And how do we do that? So we can see, if we should print out our B array here, we can see this is a two-dimensional array and our C2 is also a two-dimensional array. Sorry. So a two-dimensional array. So if we want to slice B now, let's say, what do we do? How do we slice B? So to slice B now, what we're going to have is just write out B, and we are going to have just a single bracket, but it's going to be in the format we use here in a way. And how is it going to be like that? So we are going to have, okay, we have been slicing like this now, and this is going to represent the row. And when we mean from index 0 to 2 now in the row, you can see here, right here, we have just 2 rows. So I'm not even sure that is applicable. Yeah, it worked well. So it's just like something as saying from index 0 to 2. So it's starting from index, this is index 0 now and index 1. So it's bringing out both index 0 and index 1, and it's not printing out the last index, which is where we are stopping now. So now this is just like giving us exactly the same thing now. That's because we are printing out the 2 row. But let's say we want to just extract some column out of this 2 row now, and some column now we can have, like, we have how many columns here? We have 4 columns here right now. That's from column 0 to 3. So we can just slice from column 0 to 1. If you do it this way, we are only bringing out column 0. And let's print that and see. Now we can see that we only have column 0 here, just like we have here, which is 1 and 5 here. So that's what we have here. And if you just have like 2 here, you see that we have 1, 5, 2, 6 here. Just this, we just have this now. So that's how it works. So we could just slice more like this, and let's say we want to have just, okay, let's see 2 here. And what do we have here? We are bringing out column 2, just column 2 here. That's all we are doing here. Okay, so this is column 2. I'm bringing it out as a one-dimensional array on its own. So if you show it like, okay, let's say 0 here, see that we're just bringing out just column 0 here. And let's try and reverse this in a way. You see that now we are picking row 0, right? And we are slicing column 0 to 2. That's 1 and 2. I'm making it out as just one single element. And just let's go back to, so we tell it like this, and we just have it more here. So we could just like B column 0 to 2 and column 0 to 1. So you have it this way now, 1 and 5, and you could just have something like B column 0 to 3. No, sorry, 2. That's this 0 now. And for the column, we could just have 2. So we are bringing out column 2 here. So that's how it works here. But let's say, can we have step like we have previously? Okay, let's see. Okay, now let's print B column 0 to 2, and sorry, row 0 to 2 and column 0 to, okay, let's say 4, because that's what we have, and step 2. So now we see we're having step of 2 here, as we printed this, but we didn't print 2 and 6. Then we print 3 and 4, but we didn't print 4 and 8. So that's how it works too. So let's work with our last array here, which is this. So now what can we do here too? We can see here now we're having, like, if you print C, we're having our array back here. Then we can just print this out now. Okay, let's just say C. So now we have 0 now to 3, and let's just print out a specific row. Let's say row 1, so column 1. So we can see now we're having column 1, which is 2, 5, 8 now. Yeah, just like that. And we could just print out now C now, and we just like, okay, let's slice it in a way, and okay, let's have just 2, and we can see now we're having it this way. And we can also have step just like what we did here, just like, okay, let's say 3, and let's just have 1. A step of 1 is just the same thing as nothing, because by default it's 1. So now we see that we skip the middle line, the middle column. So this is how slicing works. So thank you very much for staying this far with us. So now we are talking about iterating and concatenation with NumPy library in Python. If you've not watched my previous videos on NumPy tutorial, you should go back and watch them so that you can understand more concepts on Python tutorials. Welcome back to my YouTube channel, Iterating. So today we are talking about iterating and concatenation, and let's get started and just import our NumPy library and send P. So we have that now, and okay, the next thing we can do now is, let's say we have an array here, np dots, okay, array. We have an array as 1, 2, 3, 4, 5, 6. Okay, 6, that's enough. And what is iterating? Iterating is going through each element one by one. So let's say we want to go through this element one by one and want to print it out one by one. We don't want to print it out as an array just like this when we print A, but we want to print out each element itself one by one. We want to print out 1, 2, 3, 4, 5, 6. So what we can just do is for I in A. So we are saying going through this element now for I in A. That means each element in A, we want to print out I. So when we do this now, we see that we're able to print out each element in A. So this is how we print out. We go through elements one by one. So we could use this same format now. You can just say for I in A, we want to print out only the elements that are even, just even numbers. So we can just check if I divided by 2, that's modulo sign, is equals to 0. So now we're checking the remainder. If the remainder of I divided by 2 is equals to 0, we want to print out I. So this way we are going to be printing out just even numbers. And if we should have this and just, let's say, like to print out odd numbers, we just have something like is not equal to, we are putting out odd numbers here now. So this is how iteration work, and you could just modify this in a way that, okay, let's have this way, and then just, if we want to add just like 5 to all the elements now, let's say we want to add 5 to all the elements, you can just say plus 5. Okay, so we're having 6, 7, 8, 9, 10, 11. So this is how we go through all the elements. So now let's say we have two-dimensional array, np.array, and why having two-dimensional array now? We want to go through this array and we want to print out each element in this array. And how do we do that? How do we do that now? So let's say we have 1, 2, okay, 1. Okay, let me use 10 now, 20, 30, and we have 40, 50, and 60. So we could print out our array and print out the dimension of this array. That's b dot ending. So we can see that this is our array now, and this is two-dimensional array. But we want to go through this, and if we should try it like the way we went through the one-dimensional array, and we should print out our here now, we will see that this is what we are getting. We get this as an array on its own, and this is an array on its own. So we are getting the first row as an array and the second row as an array. So to solve this, all we need to do is, like, now we've gone through this now the first time, we've gotten this I. The next thing we are going to do is now we want to go through it again. So we j in I for the first instance now. This is our I, right? So for the second instance now, j, we are going through this I. That's now j will now be 10, 20, and 30. We want to print out what? J. So we can see this now. So if I should just bring this up here, you see that, okay, this is the I, and now j is going through the I. We're having 10, 20, 30, right? If I could just comment this out now, you see we're having this now: 10, 20, 30, 40, 50, 60. So this is how we iterate two-dimensional array. So, and if you want to do like, we want to print out just the even, they are even actually. Okay, so what can we say we want to print out? Okay, let's say we want to just add 5 to everything there, plus 5. So you could see them this: 15, 25, 35, 45, 55, and 65. So this is how we go through two-dimensional array, and this is how we iterate two-dimensional array. So now we're going to be talking about concatenation. And what is concatenation now? So I just have concatenation here. What is concatenation actually? Concatenation is adding two arrays of the same dimension. They must be the same dimension. They must have the same dimension together. So this is what concatenation is all about: adding two arrays of the same dimension. So let's say we have array A to be set to 1, 2, 3, 4, 5. Now we now have array B to be set to 6, 7, 8, 9, 10. So we could print out, okay, A now, A, then we print out A. Okay, print out, okay, we have B now, and print out. There should be a comma here. I'll print out B, right? So this is our A and this is our B, but now we want to join the two of them together. What we could do, we could have C as an array, and we could just say np dot call a concatenate function now. Concatenate now. So how do we concatenate? We have it as a tuple here, and we just like concatenate A and B. Sorry, A and B. So let's print out C now. So let's just have it as C. So if you print out C now with C, we're having all the elements joined together. So this is how we simply concatenate, and we just join it together. And this is because they are both one dimensional. A and B are both having just one single dimension. So let's say now we want to concatenate 2D, concatenating two-dimensional array. Okay, let's say, okay, concatenating 2D arrays. So how do we go about this now? So let's just say we have x to be equals to np dot array. Okay, np dot array now, and let's just have it as 11, 12, 13. Okay, we should have a parenthesis here. Let's have it like 14, 15, 16. So let's have it as 14 here. So this x now, and our y array is now np dot array. (21, 22, 23). Okay, 24, 25, 26, right? Okay, let's have it this way now, and let's print out both arrays. So let's say we have x now. Okay, and we'll print out y2. So what do we do now? Okay, So we have this as our array now, both x and y. So we have x here, we have y here. So these are our arrays now. So we just remove this so they go. Okay, let's leave them this way. So now I want to add these two together. We could just have z set to np dots concatenate now. Concatenate, and we are concatenating x and y. Sorry, let's print it. So now we can see that 11, 12, 13, 14, 15, 16, and this now has been concatenated. So if you should just print out the shape of one of these, a bit two of them actually, you'll say, okay, x shape now, x dot shape, right? And we'll also print out y shape, y dot shape, right? So you can see this is 2, 3 now, the same structure, the same dimension. So we could print out z shape now, the shape of z, and compare this. As z dot what shape. So when we print out this now, you can see this is 4, 3. And this is 2, 3 now, that's 1, 2, and this is 4, 3, right? That is 1, 2, 3, 4, right? And 1, 2, 3. You can see it added these two together, these two rows together, and we have a 4. But now anything that is more than one dimension, so that's 2-dimensional, 3-dimensional, we have other argument that we could use in this concatenate function, which by default we have axis, and axis is set to 0 by default here, and that's how we have it like this. But if we set it to 1, we see that instead of adding the rows together, it will be adding the columns together, and this will now be placed somewhere here at the back here. So let's just set this to 1 and check it out now. So we can see this way. So let me return it back to 0 and run this. So we just copy this and let me paste this here and set it to 1. So we could see this now. We are now having 2, 6, 4, 3. First, we added these two rows together to get 4 rows. That's how we concatenate 2 of them. And now we are adding the column instead together to get 6. But now we are leaving the distance together, the rows to be still with 2. That's here and here. So you can see we just cut it out from here and added it at the back here. But before we just added it under, but now we're adding it to the right hand side. So this is how concatenating work, and this is how iterating work. So welcome back to our NumPy tutorial part 5, and this time I'm going to be talking about splitting NumPy arrays. And what is splitting? Splitting is just the reverse operation of concatenation, and it's simply breaking down one array into multiple arrays. So in splitting, we take an array and we try to break it into different arrays, like multiple, based on the number we specify. So let's try splitting an array now. Let's go ahead and import our NumPy as np. So we would like to start working with one-dimensional array first. So let's try splitting arrays. So let's say the first array we have here are array of names, and we just have some names of some boys here. So you'll say np dots array, and let's have Andrew, Paul, Peter, Max, John, so we have Matt, let's have Mark. So we have, okay, let's add one more to make it 8. So let's say we have Samuel. So we have this array that contains 8 names now. So we could just have another array called name split, and we just use this function called array split. And this array inbuilt function called array split is actually takes 2 arguments in the case of one-dimensional arrays. But when we are talking about two-dimensional arrays, we're going to be having like 3 arguments there. But we'll talk about that when we get there. So this actually takes 2 arguments, and first one will be the array and the number of division you want to have. So let's say we want to have just 2 division here. We could just have it like name split here and grab this division. So what we could do here now is just let's try and print the name array and print also the name split itself. So running this now, we'll see the main array here itself giving us 8 people, 8 names in the array. But we can see the name split now. We are seeing that we are having a list of arrays, and this is the first array here, which contains just 4 names, right? And we're having the second array which contains 4 other names. So we took this name right from the index 0, 1, 2, and 3 and put it in the first array here. That's Andrew, Paul, Peter, and Mark. Then we take the remaining and put them in the second array. So let me have name split 2 now. Call it name split 2, and let me just add this array as np dot array split. So let's split name and let's have it as 3. Let's have it as 4 so they'll be even. And let's print it out. So we can now see the same thing happens here. So we're having an array, 4 arrays now, and they are just containing 2 names each, not like the first name split here, which is just 2 arrays. We can see the difference between them just because of this argument we specify here. So this is how array work for one-dimensional arrays. Okay, this is how it works. But let's say we just want to get just one of these. We don't want to get all the arrays. We just want to get the first subset of the array here. We could just say, okay, this is name split 2 now. So this name split 2, we could just use this square bracket and the index of that array, and we will get the first array here. And you will see if we should copy this now and just paste it here again, and now we specify 1, we'll be getting the second array on the list there, as we can see here. So this is how it works here. And if you should like make this name split itself, we'll be getting this second array here, while this will be giving us the first array itself. So this is how we use index to get a subset of just like a single subset of the array itself instead of printing everything out. So let's say we have array of numbers and we call them nums. We just have array of numbers now. Let's have np.array. So we have 1, 2, 3, 4, 5. So we have array of numbers like this. So I want to call them like num split. So I like using splits, but I think that work quite alright for me. So we have num split here, and we just have split. And let's say we want to split nums now into 5 parts. So let's just print this num split out, and let's see. Now we're having this 1 to 10 here, splitting it into 5 parts. We're having it as what? You can see we're having it here now as giving us 5 sub-arrays having 2 elements individually. They are all having 2 elements individually. But let's not say we want to print this out. We want to print this element itself out itself, like just print each array itself. Like just like printing each array. So we can use a for loop to go through this, and we could just know that, okay, since we know that the numbers of arrays is 5, we could just say for I in range 5. What we could do here now is print, and I would like to use a formatted string, and let's say the sub array, and I would like to have the number, the sub array 1 is this, and now I would like to have I, and this should be in a curly braces. I like to have I then plus 1. You should have guessed why we're using this plus 1 is because we use zero-based indexing in Python, and to make up for that we have to add 1 to every index we are having, because now 5 will be 4 while representing it with index. So let's have this now. You see, okay, I think there's an error somewhere. Okay, it is num split. So we have it like this now. We have the sub array 1, we have it as 2, sub array 1, sub array 2, sub array 3, sub array 4, and sub array 5. So this is how it is. It splits it into different parts now. That's how it just work. So now let's say we want the user to enter the number of split the user wants. We just copy this and let me paste this back here. And instead of having this, I want to have a variable here which I called split. No. So I could just have it as int input, and let's say enter number of split. Then we want this 5 now to be split. No. Then what we want to do now is, okay, let's say we want to print this out first. Then after printing this out, I want to have for I in range. For I in range split, right? So let's print out this. So let's have it this way. Okay, I think we are good to go. So let's work with this now. So it's asking us that how many arrays do you want to split this into. You know, we've all been working with arrays that give us even distributed. This is 1, 2. All of them are having 2 elements in the arrays, and the former one here is just like 4, 4, and it's having like equal elements in the arrays. It's having like equal elements in the array. But what will happen if you give this 3 and we're having an element of 10? Like 10, an array of 10 elements. So let's check it out. Okay. So this should be split, no? So let's run this again. So what will happen if you give this 3? Now we can see that it try its best to distribute this evenly, but you can see that it just find a way to make sure that it's giving us 3 sub arrays, and that's what it's just going to try to do. It doesn't care whether it's equal, but it will try its best to make it equal. So let's just run this again and let's give this 6. Now you can see now that we have 4 that are having 2 elements and just 2 sub arrays having just a single element. So this is how it works with sub array. That will be all about splitting 1D array. So let's now see how do we split 2D arrays. So let's talk about 2D arrays. Okay, I say splitting 2D arrays. Actually, there's no difference in splitting 2D array. The only thing that we might have that can be a little bit different is just that while calling the array split function, we have opportunity to add one more parameter to it. So let's just say we have an array called a here, and we have np dot array, and we just have this to the array. Okay, let's have it this way. I have 1, 2, 2, 3. Okay, let's have 4, 5, 6. Let's have 7, 8, 9, 10, 10, 11, 12. So let's say we have this 2D array here. So let me just try and print this and see. Yeah, we have this 2D array here, and if you should check the shape, we see that we're having 5, 3, and the dimension of this array, we're having 2-dimensional array. So this is a 2D array here now. So let's say we want to split this 2D array. And how do you do that? It's just like, we can just say we have our split here, and we have, can I just call it a split, and we have np dot. Now we split. So we have the array first, and we have the numbers of splits we want to have. So let's give this 3, and yeah, we could just print out a split. So now we can see we're having 3 subarrays here, and now they are not evenly distributed, but yes, we're having 3 subarrays here. So now the parameter we can add here is the axis. In a way, the axis we want to print it out. So we have the ability to add the axis, because now we can print it either in the first dimensional way or the second dimensional way. Now just like talking in terms of row and column. So if I should have the axis to be 0 and now we can see it's the same thing. This is telling us that by default this axis is set to 0, but see what will happen if I set it to 1. Now you can see the way it's printing this now. So in case you don't understand this, let me just multi-bit. So you can see that now as the axis is like this, as the axis is 1, it's printing out this row, this column, and this column first. This is 1, 4, 7, 10, 13, and 1, 4, 7, 10, 13, and that's just how it print out this 3 array, just like that. That's how it print out this 3 array here. But now if this is set back to 0, you see that it's printing out it like this: this 2 row, this 2 row, and this single row, and these are it's printed out. So this, as you just specify the kind of whether you want to split the array in terms of column or in terms of the row, the structure at which we want the array to be splitted. So and we could loop through this just like we did before. So we could just let's say, okay, let me just leave this as this, and let me just copy this code. Let's have it here. So we could just say for I in range. Okay, now in range 3, because we're splitting it into 3 equal parts, not equal, into 3 subarrays. So print. Okay, let's have these 2. Let's say this sub. So 1 plus I. So let's try and have new line here. I think it should be like this. Okay, let's have a split. So now we can see this is the subarray, the first subarray, the second subarray, and the third subarray here. But let's say if I should change this to 1, now you can see it now at the way it splitted it. So this is just the difference between it splitting 2D array and 1D array is just this other parameter that we're having. So that's just how it is. And now you could just access each element itself. Okay, each subarray itself by just printing out this. A split 0 and a split 1. Right? You could access them just like this by printing out each subarray itself. So let's talk about some basic arithmetic operation in NumPy. So let's import NumPy and as np. Okay, now we just have 2 arrays here, np dot And let's have array b np dot array. Okay, so let's have these two array and let's print this. Let's print out the two arrays. So let's print out a. And one more thing, I like to use this parameter, so I'll make sure that they're on the same line. Okay, let me just copy this code, duplicate it to them. So now I have these two arrays here, array A and B. So let's say I want to like work on some addition, subtraction, and just some basic arithmetic between them. And let's see how it's going to be like. Let me just copy this again and let me have same thing here. And the only difference right now is just another one of this, then one of this. And let's start with a plus b. So I want to have a plus b, right? Then a minus b. I want to have a minus b. A minus b. So this for two other operations. So we have multiplication, that's asterisk, multiplication, and we have division. Division, but let's have our division this other way, because the elements in array B is greater than the elements in A, the corresponding index, that's 1, 10, 2, 20. So let's have it this other way around. And we also another one just like this, but now just a single slash instead. Yes. So let's print out this and compare it. So we can see now, so that this is our array now, and these are the result of what we printed. You can see that the first arithmetic operation we're seeing here is the addition, and if you notice, the two arrays, they are just adding the first elements to each other, like the corresponding elements. So this is index 0 now. We have 10 plus 1, that's 11. 2 plus 20, that's 22. 3 plus 10, that's 33. So that's what it's just basically doing. Now you can see that for this second array now, we're just subtracting them from each other. We're just subtracting them from each other. So 1 minus 10, that's minus 9. Then 2 minus 20 minus 18. So this is how we are just like doing it. And for the multiplication, it's same thing. And you can see the difference between this now. Using these two division, we are making sure that we are not having any decimal, any remainder, but not using it is giving us remainder here. And that's why all these are float value. Actually, the remainder is 0, but using this is actually telling the program that we are expecting that anyone could be a decimal, something like that. So if I should put this as 75 now, okay, let me put this array as 75. Let me run this again, run this again. Now you see that the one that is 75 is actually giving us a float here, but right here, while using this, it is not affected, but it actually gives us a float here. As you can see, it actually gives us like some decimal points at the back, but here it is not affected. So this is actually like rounding it off and just like eliminating the remainder. It's giving us without the remainder, assuming that there is no remainder, assuming that there is no float. But here it's actually giving us the way it is divided. That's like it is. And we also have this modulo sign. So let me change this back to 17. Now let me select it this way. Copy this. So let's try using this. Now you can see that this is actually just returning only the remainder. While we divide 10 divided by 1, there's no remainder, so it's giving us back 0 actually. And that's why all these ones are not having any decimal point at the back. But when we get here, give us 5. That's because when we divide 7 divided by 75 divided by 7, that's 7, remainder 5, right? So it's actually giving us the remainder back. So these are just the basic arithmetic operation. So let's proceed. But before we proceed, what do you think will happen if they were not equal? Let's say the arrays were not equal. Let me just change this back to 7, and then say this, they were not like equal length, they were not having like equal item size. Now you can see we're having an error because they are not having the same dimension. So we could not progress together with shapes 9 and 10. They are not having the same dimension. Sorry, not the same dimension. They are not having the same numbers of elements. That is the item size. So we can see they won't work that way. So now let's proceed to how we can work with arithmetic operation with 2D arrays. So we could also have like 2D arrays now. Let's say we have same A and B. Okay, let me just copy this and make some modification. Let's just have that same A and B. And now the difference now is just that. Okay, I like to space them out this way. So let's have them this way, and let's do the same thing here. So let's have them this way. So we have A and B just like this. So what do we? Okay, let's try and print them out. Okay. Print B just to ensure everything is working fine. So we have them working quite alright. So they're working quite alright. And the next thing we could do now is just try and perform some basic operation on them. So I like to copy some of my code from here. So let's have this code. Okay, let me just use this. So let's have this code here. And what do we want to do now? Just same thing. Let's see how some of them work now. Let's see. So I just like to add one more thing here. Let's say that's new line. Should I rather remove the end? Yeah, let me try that. So I'm just run this again, and we could see the way it is now. Sorry, actually didn't give me the result I was expecting that. Okay, now I can see that these are the two elements A and B. I can see A plus B now we're getting 11, 22, 33, just like the one-dimensional array. It's just doing the same thing, like adding them together. That's what it's basically doing, is adding them together and just performing same operation, but it's just like the same thing is applicable to a 2D array. Now we can see that it's giving us back those elements as a 2D array. It's just performing same thing like it did with the 1D array we had here. So it's just performing same operation and it's giving us the result in 1D array, in 2D array I mean. But if you should look at all these 2D arrays, they look matrix-like, right? In form of matrix. So there's a way that we can perform some matrix operation like matrix multiplication and transpose with NumPy here. And how can we do that? Let's say we have our A. Let's just print our A and B again. And print our B also. So we have these two operations, and let's say we want to have a matrix multiplication between two of them. We're just going to use the @ sign here. So if you just print A at B, now we see that this is exactly a matrix operation here. You can try and verify this by just trying to calculate it in the matrix-like way. You can see this is just like the multiplication of matrix A and B. Matrix like. So I also said we can perform transpose, right? And to do transpose, we just have to use some. I hope you remember that transpose turn row into columns and columns into row. So let's just get our A again. You can see that this is our array A, which we can call matrix A. And now let's say we want to get the transpose of this A now. We want to save it as C. So let's save the transpose as C. What we can simply do is there is a function with NumPy called transpose. So we can just call that function here, and we could pass in the parameter, which is the array we want to have the transpose. That is A now. So now if we try and have C printed, we see that now this is A, right? And the first row here is 1, 2, 3. Now we can see that the first row here is 1, 4, 7, which is the first column here. And we're having the row here as the first column here. So it's just like interchange the two of them. So this is how transpose work with NumPy array. Hello everyone, welcome back to my YouTube channel Code Tracks. So today we are going to be working on statistical operation on NumPy array, and we are going to be using some basic statistic techniques that are called descriptive statistic to work with our NumPy array. So let's start by importing our modules. So we are going to import NumPy as NP, and we are going to as NP. I'm also going to import one other module, that's statistic. So import statistic as st. So let's run this. Okay, now we have successfully import the module now. So let's work with an array. Let's say we have a one-dimensional array here. Okay, let's just have 1D array first. So let's work with one-dimensional array. So let's say we have an array here. And just have 10, 12. So let's say we have this array here, and we want to have some we want to get some statistic information about this array now. What can we do now? Let's say we want to have the largest element in this array. We could just say print now. Let's just have print, and we could just have something like let's have largest element is equals to, and now you can just say a.max. By calling the function max, now it's going to print out the largest element in the array for us. And now we can say the largest element is equals to what? 30. And if you look at the array, that's the largest element we have. So let's continue now. Let's say we want to print out the smallest element. So we could just copy this. So now I want to say the smallest element now, and this will now be a.min and not max. Now we see that the smallest element is 10, and that's what we have here right here. So now let's say we want to print the sum of all the elements we have here. Sum of elements. So we could just do a.sum, and we see we have 186. And this is just the addition of all the elements we have in here. And we could also find the mean, and the mean is just like the average, right? So we could just say mean of the elements, so let's have mean of the elements. Let's here, I could say, and this we have to use the NP function, that's the array function. That's the array function mean, and we pass in the array we want to find the mean right here. So we print this now, we can now say that this is the mean of this array, and we could just similarly find the median of this array. So just say median of the elements. So and here we could just have median instead. Just have median instead, and we could run this and see. So now let's talk about the mode. We could try looking for the mode. NumPy has no attribute mode, and that's why we import this statistic in first place. So instead of using the NumPy now, because NumPy actually have no attribute like mode, we could just use, okay, let me save it as mode. We use st instead. Now we are calling on the statistic module to perform that operation for us. And now we are saying that the mode is 10. That's because 10 is the most common element here. 10 appeared twice. Sorry. Yes, 10 appeared twice. So next thing we could do now is look for the standard deviation of the element. And okay, you know that in element we could have standard deviation. Let's say we have standard, let's have elements. So now this will just be np dot, not, yeah, we don't need to use np. You can just use a dot std to do this. So once we use a.std, it's going to give us the standard deviation of the element, and we could apply something similar to this to find the variance of the element. So I just have like this. We have the variance of the element, and this, you know, the variance, that's VAR, just VAR. We will see the variance of the element. So these are just some basic statistical operation with NumPy. So let's implement this to a 2D array now, and let's see how it worked today. So I would like this to be marked down. So okay, just call it P instead. So like to have np dot array here. So we have 1, 2, 3. And so we have 1, 2, 3. And we have 4, 5, 6. Then we have 7, 8, 9. So if you have it like this, okay, let's print B out and see. Now this is our array. So we could just apply the same operation we have here. So let's copy this, not just element, and let's paste it here and just change this to B. So now we are seeing that we are returning 9 as the largest element there. And let's see the smallest element, and we could just apply that here. So we can see that, sorry, this should be changed to B. We can see that the smallest element in the array here is 1, and that's what we are returning here. So we have the sum of the elements too. Could do that and just copy all these. So we are going for the sum of the element next. So sum of the elements now, could just copy it out here and paste that here. That would be, so now we have the sum of the element now to be 45, and that's very correct if you should use your calculator. So next thing we do now is, after the sum of the elements, you are finding the mean. So we should look for the mean now. So that yes, the mean is 5. So we have 9 elements and the sum of the elements is 45. So 45 divided by 9 is giving us 5. You can see that that is correct. So and the next thing I will look for is the median. So we can run this and consider the median now is 14. Consider the median now is 5. And if you check here, we have 4 elements to this side, 4 elements to this side, 5 is at the middle. So 5 is the median. So let's check the mode. Let's forget to change this to this. Okay, so I believe this mode does not work for array like this. Let me try changing this to 2, 3. Okay, so I think mode does not work for 2D arrays. So let's take this back to 9. So next thing I will do after all this, let's see if you can get it standard deviation. So yes, we have the standard deviation already, and we can also have the variance of a two-dimensional array. So the variance, so we can get the variance. So now you see, now we are having the variance here. So the next thing we are just going to do now is having, so there is a third parameter we could add to some of this operation when we are working with two-dimensional arrays, and that's just like specifying the axis in some of the applications. So we can just specify the axis. That's either to give us for each column, yes, for each column now. So we could just like, okay, now let's just say, let's start with the largest number here. So we have B here, and the largest number here. Now we could just say axis equals to 0. So now we are getting the max number for each column. So let me have B printed out here. So now you can see that in this first column, 7 is the biggest, is the largest number, so we have 7 here. This second column, 8 is the largest, we have 8 here. And in this third column, 9 is the largest, we have 9 here. So we could try just doing the same thing here. P, and let's have the axis set to 1. So now when the axis is set to 1, we are getting the largest number in each row itself. So now we are having 3, 6, 9 as the largest number in each row. So we could work the same way like this with the smallest number too. So let's say we have the smallest number here. We have B, mean, and we have the axis to be set to 0. So now the smallest number here is 1, 2, 3, and that's why we are getting it. Smallest number in this column, in this first column, is 1. This second column is 2. In this third column is 3. So okay, let's have another array here called C. So you can just have some numbers that they are not in a particular order. So let's have 1, 5, 7, 89, 43, 58, 'So let's have this array here. Let's have this array here, and okay, we could just print C out. Okay, we have this array here now, so we could just apply the same thing here. Let's have the largest. Okay, let's say we have the largest now. Let's just do C dot max, and we have the axis to be set to 0. So now you can see that now in each column we're bringing out the largest number there, and you see in this first column it is 9 is the largest, but in the second column we are having 67 as the largest, and in the third column we are having 67 too as the largest, and that's why they are separated like that. So this will also work for the smallest number. So let's have 8 points. Smallest number, let's have C, and let's have it by the row this time around. And we're having the smallest number in this row to be 1, and in this row to be 43, and in this row to be 6. So that's how it is. So now let's also work with some other operations. Let's have like sum of the element now. So if we should have sum of the element here, sum of the elements, so we have it here now. We could have B, and let's have the axis to be set to 0, and let's have that same sum of elements. So let's have C, and let's have the axis to be set to, let's have B here, C here, and let's have the axis here to be set to 1. So now we are getting 12, 15, 18. And what is happening here? If you print out both B and C here, you see that when the axis is set to 0, that's 0, right? If you should add this together, you are getting 12. 1 plus 4 plus 7 is 12, and that's why we're having 12 here. And 2 plus 5 plus 8 is 15. That's why we're having it here. And here now we're adding each column together, and we are giving it to us as an array. But right here we are adding each row together. 1 plus 5 plus 7, 13. 83 plus 43 plus 67, 199. Then 23 plus 67 plus 6, that's 96. So we're adding each column together, each row together, right here, when we are setting the axis to 1 to give us this. So we could also have the mean. So let's check out how the mean be. We could also have the mean here. You'll see mean of element B here. Alright, here now we just have another parameter here, and we have the axis. I'll set the axis to 0, and let's make this B, and I'd like to just have the same thing here. C, and let's make this 6. So I'd like to set this axis to 1. So now we can see that now we are having the mean of each column here, the mean of each column here, and the mean of each row for this side. And that's how it works, and that's how we have it here. Just the mean, the column, and the row. So we can also work like that with the median. So you can work like that with the median, and for the median we just have for B. So, and I'll set the axis to, let's have the axis to be 0. Let's see. So now this is the median now, and you can see that for this view it's just returning all the elements here. That's because that's how it's meant to be. We have 3 elements in each column, and it's just giving us all the elements. So now if you change it to row, you see that we are getting all the elements here. That's 258. So let's try it out and see. Yes, we're getting 258 because that's the median. So we can also have it, we can also like have it to standard deviation and variance. So now we have B. Now we can just set axis here, and now it's giving us standard deviation for each column, but when we change this to 1, it will give us standard deviation for each row. And for the last but not the least, we have it for the variance. We have it for the variance, and we could have this as B and this axis. This axis can be set to 0. And now you see that we're having the variance for each column here, and now for each row. So that will be all for today on statistical operation on NumPy array, and with this we've come to the end of this mini series on NumPy tutorial. So thank you very much for staying so far with us. If you're not subscribed to my YouTube channel, be sure to subscribe to it, and if you like what you've watched, make sure you like this video. So see you next time when I'll be posting another tutorials on Python. It could be TK, Inter, King, or any other Python tutorial. Thank you very much. See you next time.